Welcome to class 12. Today we have the first class of chemistry. Before we begin, I would like to just tell you we have two volumes of chemistry in class 12 as we had in class 11. Volume 1 includes chapters based on physical chemistry and inorganic chemistry, whereas the second volume includes chapters based on organic chemistry. The theory paper carries a weightage of 70 marks and practical examination carries a weightage of 30 marks. You have to pass separately in the two examinations. As regards the weightage chapter wise, tentative weightage is given by the board but it may vary also. Just as we had the paper in the final exam, the pattern for the board examination is the same. We have section A in which we have 20 questions which may be MCQ, reasoning accession type, fill-ups, etc. Section B includes 7 questions or 2 marks each, and section C includes 7 questions or 3 marks each, and section D includes 3 questions or 5 marks each. There may be internal choice. Okay, now let's begin with the first chapter, that is solutions. The first chapter which is given in NCERT, that is solid state, is not in our syllabus. So you people are already familiar with solutions. What are solutions? We all know a solution is a homogeneous mixture of two or more than two substances. The composition of the solution may vary depending upon the number of components a solution has. We have different types of solution. It may be binary solution. Binary means two components. It may be ternary solution, means three components, and the quaternary solution having four components. The components of a binary solution, there are two components, namely solute and solvent. The component which is present in lesser concentration is regarded as solute, whereas the other component is regarded as solvent. Now we have another classification of the solution. This is based on the physical state of the solution. It may be solid solution, it may be liquid solution, or it may be gaseous solution. Now, the solid solution is the one in which solvent is always solid, but the solute may vary depending upon the solute. It may be solid in solid solution. For example, all your alloys come under this category. Then we have liquid in solid solution where solute is liquid and the solvent is liquid. For example, your amalgam, say sodium amalgam or zinc amalgam. So mercury is dissolved in zinc, or sodium is dissolved in mercury is dissolved in sodium. Gas in solid solution. For example, gases adsorbed on metal surfaces like hydrogen gas adsorbed on palladium, platinum, nickel, etc. Then we may have the second type of solution, which is a liquid solution. Here the solvent is liquid. Again, like the earlier case, if the solute is solid, it will be solid in liquid solution. For example, salt in water, sugar in water, copper sulfate in water, endless examples are there. Then we have liquid in liquid solution. The mixture of miscible liquids come under this category. For example, alcohol and water, ethanoic acid and water. Then we have third type of liquid solution where the solute is gas. The examples are aerated drinks, the cold drinks of which you are quite fond of. In cold drinks, CO2 is a solute and water is the solvent. Oxygen dissolved in water is another example. Then we may have the third type of solution, that is gaseous solution. Here the solvent is gas. Again, it may be of three types: solid in gas solution, for example camphor in nitrogen gas; liquid in gas solution, for example chloroform in nitrogen gas; gas in gas solution, for example air. So at least one example you should have of all these solutions. Next that we have to study is concentration of a solution. Though we have already studied about the concentration or solution in class 11, let's recapitulate. It may be expressed in terms of percentage. It may be percentage by mass, that is percentage W by W. It means the amount of solute, that is mass or solute, present in 100 grams of the solution. Mathematically, percentage W by W equals to mass or solute upon mass or solution multiplied by 100. We may have percentage by volume, that is percentage V by V. It simply refers to the volume of solute present in 100 ml of the solution. Mathematically, percentage V by V equals to volume of solute upon volume of solution multiplied by 100. Likewise, we have percentage mass by volume, that is percentage W by V. This concentration term refers to the mass of solute present in 100 ml of the solution. So mathematically it equals to mass of solute upon volume of solution multiplied by 100. This concentration term is used in pharmaceutical industry, that is in the preparation of medicines. Next we have parts per million, that is ppm. This concentration term you already know. It refers to number of parts of the solute present in million parts of the solution. So mathematically ppm will be equal to number of parts of solute upon number of all the parts of solution into 10 raised to the power 6. Here the parts of solute and the parts of all the solution may be taken in terms of mass or volume. This concentration term is used to express the concentration of pollutants in air or water, which is quite less. A very important concentration term which is quite useful is molarity, represented by capital M. It may be defined as, we have already studied in class 11, as moles of solute present per liter of the solution. So mathematically, molarity comes out to be moles of solute divided by volume of solution in ml multiplied by 1000. If there are two components, then we write molarity. Moles can be written in terms of weight and molar mass as W2 upon M2 divided by volume of solution multiplied by 100. For solvent, we use 1 and for solute, we use 2. The unit of molarity is moles per liter. We may have various solutions. The solution whose molarity is 1 is 1 molar solution. We may have solution whose molarity is 0.5 m. This is semi-molar solution. It may be 0.1 molar, that is decimolar, or it may be 0.01 m, then it is centimolar solution. The next important concentration term is molality, which is represented by small m. It may be defined as the moles of solute present in 1 kg of the solvent. So mathematically, molality is moles of solute upon mass of solvent in grams multiplied by 1000. If you want to write it in terms of weight and molar mass, we write molality as W2 upon M2. This will give you moles of solute divided by mass of solvent, that is W1. So on solving, it comes out to be W2 upon M2 into W1 into 1000, or you can write it as, in place of W2 and M2, substitute N2. So it comes out to be N2 upon W1 multiplied by 1000. The unit of molality is moles per kg. One very important thing you should keep in mind, it is generally asked in exam, which is better concentration term, molarity or molality. So as molarity is temperature dependent because it involves volume, and volume varies with temperature, whereas in molality we use concentration, we use mass of the solvent which is independent of temperature. So obviously molality is better concentration term than molarity. Now mole fraction, this is very important concentration term This is used to relate with the physical properties of the solution you will study in the later part of the chapter. You have studied in class 11 mole fraction, represented as chi is the ratio of moles of a component to the total number of moles of all the components present in the solution. Mathematically, mole fraction, that is chi, equals to moles of component upon total number of moles of all components present in the solution. For a binary solution which has two components 1 and 2, so chi 1 will be equal to n1 upon n1 plus n2, and chi 2 will be equal to n2 upon n1 plus n2. If you have found the value of chi 1, you can find out chi 2 by subtracting it from 1, because chi 1 plus chi 2 will always be equal to 1. The sum of mole fractions of all the components in a solution is always 1. Now, let's do some numericals based on these concepts so as to strengthen the concepts of concentration of the solution. So, see example 2.1. The question says, calculate the mole fraction of ethylene glycol. The formula is given C2H6O2. It may or may not be given in the exam. So you should know the formula and molar masses on your fingertips of some common substances. The 20% by mass of the solution. So first you have to find out the moles of ethylene glycol. For this you need to find out the molar mass. So it is C2, that is 12 to the 24 plus 6 into 1 30 plus 16 to the 32. It comes out to be 62, or you should remember by heart that it is 62 grams per mole. So moles of ethylene glycol equals to 20 upon 62, which comes out to be 0.32. The other component is water. It is 20%, so mass of water is 80 gram divided by its molar mass, that is 18. 18 fours are 72, so it comes out to be 4.4. So chi 1, that is mole fraction of ethylene glycol, will be equal to 0.32 upon the total number of moles of both the components. It comes out to be 0.068. So if you have to find out the mole fraction of the other component, simply subtract from 1. It comes out to be 0.94. See question number example 2.2. It says calculate the molarity of a solution containing 5 gram of NaOH in 450 ml of solution. So the formula is moles of solute. So moles will be, the quantity of solute is 5. So 5 divided by 40, it comes out to be 0.12. So using the formula, it comes out to be 0.12 divided by 450. As the volume is given in ml multiplied by 1000, on solving it comes out to be 0.26 moles per liter. Always underline the final answer and write the answer with units, otherwise half mark will be deducted for the same. Let me take example 2.3, which says calculate molality of 2.5 gram of ethanoic acid in 75 gram of benzene. Now moles of ethanoic acid, this is 2.5 divided by molar mass. Calculate the molar mass. It comes out to be 60 gram per mole. So it comes out to be 0.04. So molality will be 0.04 upon solvent is 75 gram multiplied by 1000, it is in grams. It comes out to be 0.556 moles per kg. Do underline and write with the unit. Then see the intakes question 2.1, 2.2, 2.3, 2.4, 2.5. You have to solve all these. I am taking a couple of these. Let me take 2.1. Calculate the mass percentage of benzene and CCl4 in 22 grams of benzene dissolved in 122 gram of CCl4. Now, what we have to find out first is percentage by mass of benzene. For this, we need the mass of benzene, which is 22, and the mass of the solution is mass of benzene plus CCl4. So this will be 22 plus 122, it comes out to be 22 divided by 144 multiplied by 100. That comes out to be 15.28. So the mass percentage of benzene is 15.28. Subtracted from 100, you will get the mass percentage of second component. That comes out to be 84.2%. Is it clear? Moving on to next question. That is your question number 2.2 from the in-text question. It says calculate the mole fraction of benzene in a solution containing 30% by mass in CCl4. So here, in order to find out the mole fraction, you need to find out the moles of each component as I have done here. So write the quantity, divide by molar mass, get the moles, write the fraction, formula a mole fraction. So it comes out to be 0.38 upon sum of moles of both the components. So on solving, you get it as 0.5. So this is mole fraction of benzene. So mole fraction of carbon tetrachloride will be 1 minus 0.5, that is 0.5. See question number 2.3, the in-text question, which says calculate the molarity of each of the following solution. Number 1, 30 gram of cobalt nitrate. The formula is given. Molar mass you should learn by heart and you should calculate. It comes out to be 297. So on finding the moles, it comes out to be 30 upon 297, that is 0.1. So the molarity will be 0.1 divided by, the volume is already given in liters, so no need to multiply by 1000. So it comes out to be 0.02 moles per liter. Now see its B part, it is a bit different. It says 30 ml of 0.5 molar H2SO4 is diluted to 500 ml and you have to find out the molarity of the solution. Here you will have to use the dilution formula which you had learnt in class 11. The formula is M1V1 equals to M2V2. Out of the four terms, you know M1, V1 and V2. Substitute the values as done and you will get the value of molarity, which comes out to be 0.03 moles per liter. So do try question number 2.4 and 2.5 as well. I am taking 2.5. Calculate the molarity, molality and mole fraction or Ki if density of 20% aqueous Ki is 1.202 gram per liter. It involves a little bit different concept or density. In class 11, I had given you a shortcut formula for such kind of questions. The formula was molarity equals to percentage into density into 10 divided by molar mass of the solid. If you know the formula correctly, use it. Otherwise, do stepwise. That is, first find out molarity, then use the formula density and get the answer. So I am using this formula. Percentage is 20. Density is 1.202 into 10 upon molar mass of Ki is 166. This you can find out by adding the molar masses of potassium and iodine. So on solving, it comes out to be 1.4. Then they have asked us to find out molality. I had given you a formula in class 11 which gives the relationship between molality and molarity as molality equals to 1000 into molarity divided by 1000 multiplied by density minus molarity into molar mass the solid. On substituting the values, 1000 multiplied by molarity, which we had calculated as 1.4, divided by 1000, density is given as 1.202 minus 1.4, that is the molarity, and the molar mass is 166. On solving, it comes out to be 1.45. Then they have asked us to find out the mole fraction. So for mole fraction, you find out the moles of Ki, that is 20 upon 166. It comes out to be this much, 0.11. Then moles of water, 80 upon 18. it comes out to be 4.4. So it comes out to be 0.11 divided by 0.11 plus 4.4, that is 0.11 divided by 4.55, it comes out to be 0.026. Now you can just try the questions given in exercise, just two questions. The first question is from your exercise. It is question number 2.4. A question of the similar kind we have already done in class 11. The question says, concentrated HNO3 is 68% by mass in aqueous solution. What should be molarity if density of the solution is 1.504 gram per ml? So it is question similar to what I have done just now. Use the formula, this density one, substitute the values as I have done, and the answer is 16.2 moles per liter. Now I am taking the question from the exercise. The next question, that is 2.5. It says a solution of glucose in water is labeled as 10% W by W. What should be molarity, molality and mole fraction if the density is this? So it is again the same kind. Molarity, use this formula, percentage is given, density is given. On solving we get the value for molarity. Then use the formula which gives interrelation between molarity and molality, the one we had used in last to last question. Substitute the values and it comes out to be 0.61 moles per kg. Now in order to find out the mole fraction, find out the moles of glucose. The moles of glucose can be calculated by dividing the mass of glucose with its molar mass, which you should remember, it is 180. So it comes out to be 0.05. Now moles of water, as it is 10%, so the amount of water is 90 gram. 90 divided by 18, it comes out to be 5. So mole fraction of glucose will be 0.05 divided by the sum of moles of both the components, that is 5 plus 0.05. It comes out to be 0.05 divided by 5.05, that comes out to be 0.009. So this is the mole fraction of glucose. In order to find out the mole fraction of water, subtract it from 1, it comes out to be 0.991. Now there are one or two questions left from the exercise which you should try. This is question number 2.6, then 2.7 and 2.8, 2.9, 2.28 and 2.29. These are the questions based on molarity, molality, mass fraction, etc. So solve these. On the next turn, I'll be taking the concept of solubility. Thank you.